Hi everybody and welcome to Organic Chem Analogies. My name is Maria Thomas and today we'll talk about benzene and why it acts the way it does in electrophilic aromatic substitutions. And I know that's quite a mouthful, but we'll figure it out. Now we've all seen this molecule, benzene. What do we know about it? Well, we know that it's aromatic, and aromaticity means it's very stable. But for the purpose of this analogy, we'll think about aromaticity and stability as coolness. Yeah, so the more aromatic or stable something is, the more cool it is. So let's think about benzene as a pretty cool guy you see around on campus. Now, if you politely approach this guy and just ask him to do something uncomfortable or embarrassing, he's probably not gonna do it. But instead, if his friends come along and ask him to do something embarrassing as a dare, he's probably gonna do it. Even if it's as embarrassing as coming to class dressed up like Elmo. Now, this is pretty embarrassing, and it's probably going to make him look uncool, unstable, or unaromatic. But he's still going to do it because his friends forced him to do it, and because he knows that at the end of it, he's going to come back to becoming this cool guy and becoming aromatic once again. So, when I talked about a polite request versus a dare, the point that I was trying to make was that if benzene is just approached by something that's weakly electrophilic, like bromine, it's not going to react and lose its aromaticity over that. But instead, if it's approached by something like this, which is actually a very strong electrophile due to this big delta positive charge, it might be more willing to react, even if it means losing its aromaticity for a while. So the first step to this reaction is to make your super electrophile. So to do this, the lone pairs in your bromine can react with something like FeBr3 to create this molecule, which looks like that. It's got a negative charge on the Fe, a positive on this middle bromine, and this big delta positive on the end bromine. And in fact, it is this delta positive that convinces your benzene to actually attack. Now, the second step is when cool guy benzene actually attacks your electrophile, your super electrophile, and loses its own aromaticity. So as you can see here in the products, cool guy benzene now has a positive charge and is no longer aromatic, no longer cool. He's in the Elmo costume. But he's willing to do it because it was a dare with a super electrophile. Now I also want to point out to you guys that benzene attacks the first bromine with the partial positive charge and not the second one in the middle. Just something to take note of. Now, our cool guy is done with his dare and he doesn't want to be staying in this Elmo costume very long. He's desperate to re-establish his coolness or re-establish his aromaticity and become like this once more. Change back into regular people clothes. So, your third and final step in this mechanism is to regenerate or re-establish your aromaticity, or rather coolness. So benzene has a hydrogen lying here that it kicks out with the help of the remainder of your super electrophile, and the electrons attached to that hydrogen, these electrons travel back to the benzene ring and help re-establish aromaticity. So in the end, you get something that looks like this, and your end products are just HBr, FeBr3. But the point is that benzene is back to being aromatic. Now, I also want you to take note of two things. First, the hydrogen that is taken away comes from the carbon that has the bromine, not the carbon that has the positive charge. And secondly, the electrons that actually attack the hydrogen and take it away come from this bond between the bromine and the FeBr3, not from the bromine or the FeBr3 itself, but from this bond. Now, the point of this analogy is to help you remember or understand the three basic steps that happen to every single electrophilic aromatic substitution reaction with benzene. Your first step is to create the superelectrophile. This is the dare that's actually going to convince your cool guy benzene to actually react and lose his coolness or aromaticity for some time. And your second step is when benzene actually attacks the superelectrophile and loses its aromaticity. In other words, this is when the cool guy actually ends up wearing the Elmo costume and going to class with that. And your third and final step is to regenerate that aromaticity that you just lost. So cool guy benzene is desperate to get that Elmo costume off and become cool once again. I hope this analogy helped you out. Thanks for watching.